Natural gas from the Utica Shale is a clean and efficient energy source that is abundant in the St. Lawrence lowlands of Quebec. Let's take a look at the horizontal drilling and stimulation processes that have made shale gas exploration so successful. A drill bit is mounted on the end of the drill pipe. As the bit grinds away, a mixture of water and additives called mud is pumped into the hole to cool the bit and flush the cuttings to the surface. The mud cakes on the walls of the wellbore, keeping it intact and preventing invasion of drilling mud into the surrounding rock formation. The hole is drilled below the deepest freshwater zone or aquifer near the surface. The drill pipe and bit are removed. Surface casing is then inserted into the drilled hole to isolate the freshwater aquifers. Once cemented, it serves as a foundation for the blowout preventer, a safety device that connects the rig to the well bore. Cement is pumped down the casing and out through the opening of the shoe at the bottom of the casing. It is then forced up between the casing and the hole, permanently sealing off the well bore from the fresh water. Once the blowout preventers are installed, the pipe and bit are lowered back down the hole to drill through the plug and cement and continue the vertical section of the well to approximately 300 meters above the planned horizontal leg. This depth is called the kickoff point, where the curve will begin so that the horizontal section can be drilled. Up to this point, the process is the same as drilling a vertical well. Again, the pipe and bit are pulled out of the hole, and a downhole drilling motor with measurement while drilling instruments is lowered back into the hole to begin the angle building process. The distance to make the curve from the kickoff point to where the well bore becomes horizontal is typically just under 300 meters. Once the curve is completed, drilling begins on the well's horizontal section called the lateral. The pipe used to drill the well measures 9 meters in length, and each length weighs approximately 224 kilograms. It takes over 350 pieces of pipe, weighing nearly 79 tons, to drill a 3,200-meter well. At various stages of drilling, the pipe is taken out of the hole for tool and bit changes and put back in. This process is called tripping pipe. When the targeted distance is reached, the drill pipe and bit are removed from the well bore one last time. Production casing is now inserted into the full length of the well bore. Cement is again pumped down the casing and out through the hole in the casing shoe, forcing the cement up between the casing and the wall of the hole, filling the open space known as the annulus. Casing the well is a very important process because it permanently secures the well bore, and it prevents hydrocarbons and other fluids from seeping out into the formation as they are brought to the surface. At this point, the drilling rig is no longer needed. A temporary wellhead is installed, and the location is prepared for the service crew, who will perf, frack, and prepare the well for production. The first of these steps is to perf or perforate the casing. A perforating gun is inserted into the casing to the targeted section of the horizontal leg. An electrical current is sent down the wire line to the perf gun and sets up a charge that shoots small holes through the casing and cement and out a short distance into the shale formation. The perf gun is then pulled out of the hole. Next, because shale is tight or compressed, the well will have to be fracked. Known as hydraulic fracturing, this is a process where water, sand, and additives are pumped into the wellbore and down the casing under extremely high pressure. Water and sand make up over 99% of this frac fluid. The remainder consists of compounds commonly found in consumer products. As the mixture is forced out through the perforations and into the surrounding rock, pressure causes the shale to fracture. This creates a pathway connecting the reservoir to the well and allows the gas to flow to the well bore. Next, a temporary plug is used to close off or isolate the perforated and fracked section of the well bore so that the next stages of the horizontal leg can be perforated and fracked. Once fracking is completed, The plugs are drilled out, allowing the gas and frac water to flow up the well bore. About half of the frac fluid remains underground. The rest is recycled for use in future fracs, treated, or disposed of at carefully controlled sites in accordance with government regulations. With many thousands of successfully drilled wells in North America, multi-stage fracking has become the standard for tight gas reservoirs. The next step is to install a permanent wellhead, also known as a Christmas tree, and other necessary surface equipment. With horizontal drilling, this procedure can be repeated several times from one pad. The pad drains a large area under the ground by drilling several horizontal wells that branch out in different directions. This dramatically reduces the impacts by decreasing surface disturbance. Once the drilling and completion operations are finished, the production equipment is installed and the surrounding land is restored. A pipeline is then built to transport the gas to Quebec's extensive pipeline network. Utica shale gas is very clean, so it doesn't have to be processed before entering the pipeline system, which reduces overall emissions. As field development expands, additional pipeline is built. Through its use of safe, proven, and innovative technologies, Questerre and its partners are leaders in the exploration of Quebec's shale gas, a cleaner energy option for today and a bridge to alternative energy in the future. The production of shale gas in the St. Lawrence lowlands is an important part of Quebec's low-carbon energy future. Developing this cleaner energy option to replace existing imports of fossil fuels will solidify Quebec's place as a strong leader in environmentally responsible energy.